Hey everyone, welcome back to the channel. So in this video we are going to look at different window functions that we can use in SQL. It's a very important topic and you will definitely get some questions in your interviews based on this concept. So let's see what actually window function is. So window function allows you to do aggregation and analytics while still keeping each row intact. So using window function you are actually doing some aggregations as well, and still your each row is intact. You're not collapsing your rows. Aggregation like sum, average, min. And a window function performs a calculation across a set of rows related to the current row without collapsing rows like group by. So it performs calculation across a set of rows related to your current row. Here rows retain their separate identities. So before window function, we had to use subqueries, self joins, or temporary table, and these were really hard to read and slow and error prone. Yeah, and it makes the SQL syntax or your SQL query really hard to understand, right? So the syntax, so you write the function name, column, and this over clause, and inside this over clause you put partition by and then this order by, and give an alias. For example, so you are doing a sum of salaries over partition by department. So you will get the sum of salaries for each department. And here if you do sum of salary over just open and close parenthesis, then here you are not partitioning your table, but here your whole table is a one window. Okay, so this is how you basically use window function. Different kind of window functions are like aggregate functions like sum, average, min, max, count. Ranking functions like rank, dense rank, row number, percent rank. And these are the functions, window functions, different types of window functions. And also like lead, lag, first value, last value. Okay, we will see example for how we can use these functions. So over is what makes it a window function, right? Partition by splits the data into logical groups like group by, but rows are not merged, and calculations reset per partition. Okay, and order by defines the sequence, right? Like a normal order by. Okay, so this was a basic brief idea about window function. Now let's see these functions like by doing some examples. So let me go here. So this is the online ID I just found, sqliteonline.com. Yeah, you can use any ID of your choice. So yeah, I just found this online, so I'm just using this for showing you all the examples. So here I have created one table here. So I'm creating an employee table with employee ID is the primary key, name, department, salary, and joining date, and I have inserted some data here. So I'm 5 employees, ABCDE, department is IT, HR, and they have some salaries and joining date. Okay, so yeah, already exist. Okay, so now let's see first if we do a group by. Let's suppose we wanted to do an average of the salary per department. So normally what we will do a group by. So we are selecting this department, we are doing this average salary because we want the average salary of each department. So and from department, and then we do a group by one means department, right? So once we do this we will get something like this. So here we are getting department HR, the average salary is this one, for IT it's this one. But as you can see here, the other, like the rows are collapsed. Now this is your new table, right? So that's what happens in group by. But if we see the whole table again here, right? So now using window function, what we can do, how we can achieve this average without really collapsing the rows. So what we can do here, so here what I'm doing, I'm selecting star, like select all the columns, and now here I'm performing the average. So I want an average of my salary, and what we wanted to have the partition by department, right? We wanted the average salary based on each department. So what we are writing this over. That's what we saw here. So this over syntax, over, and then we are saying partition my rows based on each department. So calculate the average salary over partition by department, and then you are giving an alias, okay, from employee. Now if we run this, now here we see we have the salary joining date, and there is no column like average salary. So if we run this, now we have this average salary as a new column, but as you can see, all the rows are still intact, right? So now it gives you the power of doing some additional thing, because your whole table is also there, and still, and now you also have this average as part of your initial table itself, right? So this table is not collapsed, just new column is added. Now each employee can easily judge their salary compared to the department average salary. This was not possible with the group by. Now you can identify who is the top earners in each department, right? So yeah, you know that your salary is this one, and based what is the average salary of the department, and you can compare. So that's the benefit of the window function. And so that's how and similarly you can also do like sum. And so here I have example of similar scenarios. For example, here is top customer per region, like the benefit of using this, what you can achieve, like you can find the top customer per region, top product per category, right? So these are the things which you can this window function help you to find. And if we come here, suppose we wanted to see the total sum, but wait, before going to the total sum, let's see this output once. So here this was my HR department, so the average salary is 55,000. So for both the rows of HR, because we are partitioning by department, it's 55,000. Similarly, three rows are from IT, so all the three rows got the same value. Okay, I hope now this is clear. And now for the total sum, what we are doing like find the sum of salary over without any partition or order by. So here we are saying get me the total sum. So if we don't write anything in the over, then the whole table is your one window, and it will just do the sum of all the salary here. So if I run this, so here we see the sum of all the salaries. Okay, so and now another thing which we can do by window function is cumulative sum. Cumulative sum, you know, right? Like first row will be 60,000, then in this row it will be the addition of rows till here, then addition of rows till this row. If when we come at row 4, then it will be the addition of salary from top till this row. So cumulative sum. So how we can achieve this cumulative sum? So we can say I want a sum of my salary over order by salary. So here we are ordering our rows by salary, so it will get ordered in like ascending order, and then we are doing a sum. And if we run this, so now here you see 5,000, 50,000. So initially here it is 50,000, and then we are getting 60,000 plus 5,000. Here it should be 11, but what we are getting here 170,000, right? Why is it happening like this? Because these two uh, rows have the same values. So that's why we are seeing like, because we are ordering by salary, so these two are the same values. That's why it is like combining and then giving you the 170,000 value for both the rows. But that's not what we want, right? And here similarly 70,000, it is adding both of these to 17 and giving you the final answer. But this is not what we want, right? So one option is we include another column so that each row gets a unique identity. So if I do here department, let's suppose, then if I run this, then you see now it works fine, because now it could able to identify each rows as a unique row, right? Earlier with only the salary, these two had the same salary, so it was just giving you a combined result of 170,000, right? But now because each row is unique, so here it is saying okay 50,000, then here it is just adding this row with this value. Now you are getting 110,000, and now comes here, it will see this one, and here again now you see, because IT 70,000, IT 70,000 both are same, right? So now it is saying that okay, I find two similar rows, so that's why I am giving the final answer as 310,000 here. But here it could able to identify a new row because these values are different, right? So if we, instead of department, if we put name, then you see here now it could able to identify a new row, right? Because each row is now unique and it could identify uh, properly. So I hope now this is clear, right? So but there is one better way to achieve this, because normally this is like easy to miss, right? And it might give you a wrong answer, because normally just we are in a habit of writing just this, and it might give you some answers like this, right? So what is the better way to do it? There is one concept of using rows between. So here what we are saying, we are just doing the sum of our salary, okay, and we want order by salary, right? But because we want to identify each rows uniquely, so what we are saying, give me the sum of my salary where my rows are in between unbounded preceding. Unbounded preceding means like from top, no boundation from top, and current row, till my current row, okay? So give me the sum of salaries between unbounded preceding, so all the values above my current row is fine, till my current row, right? Between unbounded preceding and current row, and give me the total sum. So if we run this, now you see here all the values are like now fine, there are no duplicates here, even though these values are duplicated. But because we are saying that unbounded preceding and current row, so when it comes here it is saying okay, in add 50,000 and this. Now when it comes here, then it is saying okay, now add this, right, till my current row. So this is a really useful concept which you should remember. And you can also do like rows between unbounded preceding and zero following. So if you write zero following, that means don't follow any rows after that. So if you run this, then output is same, right? And if you do like one following, then you see it unbounded preceding. If you are in this row, unbounded preceding plus follow one more row. So if you are initially, it is just adding these two, right? So yeah, so you can either do zero following, or you can do like how we did it before, like with the current row. Okay, so I hope now this syntax is clear, right? Yeah, I hope you are taking notes as well, because this is an important concept. Like window function in general is very important, and more, and also like this is important, so you should definitely know all these things. Now this was your yeah, sum, and similarly you can just do min, max, whatever you want. Okay, so here if we are doing min, then till here the minimum value was this. When it comes to this row, it is finding minimum values till this point, unbounded preceding till my current row, which is 50,000. So all the values are like 50,000. When it comes here, it is saying okay, find the minimum unbounded preceding till here, which is 50,000. So 50,000. If we do max, so syntax is same, so I'm not changing the syntax, I'm just changing the function. So till here, now you will see this values, so it makes sense, I hope. Similarly you can do like count and other functions. Now let's see this row number. Okay, another window function. So here we saw like sum, average, min, max, count. Now let's see this row number. Okay, so another function here. So what row number is giving you? We are saying give me a row number over partition by department, and order by salary descending. And if we run this, then because our table is partitioned by department, so two partitions are like HR and IT, these are the two partition. So whenever you are doing this partition, the ranking will, row number or rank whatever, will start again from that new partition from beginning. Okay, so here we are assigning a row number, so order by salary descending. So HR, this was the highest salary in HR, so we got row number 1. Here the next salary was this one, row number 2. Now the department changes, so our row number starts again from 1, and then 1 2 3, right? Because we are doing a row number, that's why this value is got 2, because this row is different, so we got 2. So we can get top n salaries per department with this one. Yeah. So this was the row number. I think we have also solved one question based on row number. If we go to our channel, I think maybe this one or this one, where we solved one question based on row number, because we have solved, definitely used dense rank in our previous videos, and rank also, I guess. Yeah, so I hope this is clear, right? I'm not sure if I'm going like too fast, but yeah, I mean the syntax is same. I hope you could able to, it's pretty straightforward. By if reading also you can understand, like give me the row number over partition by department. Okay, divide partition by department, order by salary descending, give me the row number. So it's that's what it is doing. So yeah, and now we can, instead of row number, we can apply a rank, simply a rank, keep everything same. So if we run this, so what is happening here? So partition by department, highest salary got rank 1, rank 2. Now this highest salary got rank 1, this was also highest salary, so rank 1. Now 60,000 got rank 3. Because we are using a rank function, so you see here after 1 it is coming directly to 3, because there was a duplicate row here, so it skipped 2. Okay, that is your rank. That's what happens in your rank. If there are duplicates, it will skip that number and it will go to the next number, because in place of 2 we found like 70,000 again. So yeah, but the rank was 1. So this is your rank. Okay, and if we use like dense rank, then it will able to identify, it will not skip any row, it will keep the numbers in sequence. So till here it is fine, but these two were the top salaries, so got rank 1, 60,000. Now instead of 3 in dense rank you get 2. Okay, so it doesn't skip any row or ranking, right? So that's the difference between rank and dense rank. Yeah, you might get this question in your interview, like what is the difference between rank and dense rank? So that is your difference. And I think mostly I think in 2 or 3 questions we have already used this dense rank. So you already, if you have not seen those videos, go and you can watch those videos, like I think in these 3 videos, and you will see the application, like okay, where and how we are using it. So based on this, now rank, you can filter and apply some other queries based on the question. Yeah, and maybe someone will ask, give me the name of the employee, third highest earning employee. So then, or the second highest, you can simply put where my rank is equal to 2. Then you will get these 2 employees who are on the second highest earning employees in each department. So these are some application. So that was your difference between rank, row number, and dense rank. Okay, row number was like each row is unique, so yeah, you will just get 1 2 3 1 2 1 2 3. Yeah, that's what we were getting. And now moving on, let me see once. Here in ranking we have rank, dense rank, row number, percent rank. So let's first see the percent rank here. So percent rank, let's run this. Syntax is same. Okay, so over, order by, partition by. If you wish to add row, like rows between, you can do this, right? But syntax is overall like is same, and just this function is keep on changing. So here what we are saying, so here we are using percent rank, so it shows where a row stands compared to others in the same group. This So here it is saying like this row is above, gives you information about this row is above what percentage of rows in its group. Lowest is 0, highest is 1. So here what is saying, we are doing finding a percentage rank. We are not partitioning anything, we are just seeing in all the departments. Order by salary. So order by salary. So here we are assigning a percentage rank. So for 50,000 it is 0, that means it's the lowest. 60,000 it is 25, so it is saying like this salary is higher than 25% of the employee. Similarly here 60,000, 25, 70,000 is like higher than 75%. So use rank internally. So how it is calculating, the formula is like it is applying rank function internally. Okay, and percentage rank is rank minus 1 divided by total rows minus 1. So for example here rank was 1 for 50,000 because the salary is arranged in ascending order. So here for this one rank is 1, so 1 minus 1 0. Yeah, 0 divided by total row, anyway 0 will come. So here rank will be 1. So sorry, here rank is 2, so 2 minus 1 1, 1 divided by total rows is 5, 5 minus 1 4. So you got the value. So I hope now this percent rank is also clear. So moving on to lead and lag, this is also important. So if we run this, here we are using a lag function. Lag is basically checking the value like the previous values. So here we are saying check the previous value of this salary, order by joining date. Okay, and we want name, salary and lag. So here we are on this first row, we are saying check the previous salary. Okay, by default the lag will be 1. So here there are no rows above this, so you will get this null value. 60,000, oh wait, for 60,000 above this was 50, so we got this 50. When it comes to this row, then it is here 60, and at this row this value 70,000 is here. So for 70,000 this row this value is here, so it's like going one down. Okay, so this is your, and for this one its value is null. Okay, so here we are saying check the previous value by 1. So by default it is like this. Okay, and let's suppose if we don't want null, we can apply a default value. If we write 0 here, that means if there are no previous value, then apply a default value of 0. So instead of null, now it is 0. Okay, so for using default value you definitely have to give this parameter. For example, if I go with 2, okay, and then if I don't give this, then what happens? Now here we are saying check the salary of the last 2 records. So for these 2 records there will be null, because for this one the second would be here, which is not available. For 70,000 now the previous second will be this one, like the previous 2 values with this one. So now you get 50,000 here, then 60,000, 70,000, right? And these 2 will be null here. And similarly if you apply 0, then these 2 will become 0 if you don't want to put null. Okay, similarly you can put any null values, whatever your choice. Yeah, default value, so whatever you want. Okay, so the benefit of this you will generally get if suppose your company wants to understand year on year, like for example in 2025 in January what was your sale, and compared to 2026 January. So here you can put like check the lag of the salary or the sales whatever for 12 months, like the previous 12 months, and give me the value. So here for January it will compare the last, it will go back to the 12 months and then it will find the value. So it can be used for analysis, right? And it is recommended to use order by, because if we don't use order by in lag, then it's kind of doesn't make any sense, right? If the values are in order, it will make more sense to get the lag like the previous values, right? In you can easily compare basically, right? So this was your lag. And similarly instead of lag we have the lead. So lag was checking the previous value, lead will check the following value. So here lead by default it will check the one row, leading one row. And so for 50,000 you see 60 here, 60 will come here, 70, then 60, then 70, and last value is null because there is nothing right below. So there is nothing below, so it won't get any value from below, so it is null. Similarly, if you want you can put a default value here 0 or whatever you want, and similarly if we put 2 then you will get same as lag. It's just that instead of checking the previous values, now it is checking the leading values. Okay, so this we will solve other questions based on lead lag as well when we will solve other questions. And but this is an important concept also, right? And I hope now this one is clear. Now moving on to NTILE, another window function. NTILE is distributing rows into groups. Okay, so here what we are doing, we are saying if we put, let's suppose 2, syntax is same everywhere. So it is saying order by salary descending and tile, bring like create two groups of this. Okay, so here we have like 5 rows and we are making two groups based on our salary descending. Okay, so these top 3 went into group 1, these 2 went into group 2. Okay, and if so here you see, because we have 5 rows, so one group is having like one more member than the other two groups, right? So if there are more members, then it will start filling up from the top group. And similarly, if we do 5, then everyone will get into their own group because there are only 5 rows, right? And if we do 4, then you see here initially these 2 members got into group 1 because we are in 5 rows and we are making 4 groups. So in one group there will be one extra member, so all extra member starts going from the top, going into top, like top group. So yeah, in one group we have these 2, then 2, 3, 4. So yeah, partition by is optional. I mean, it is optional, it was optional in other window function also. Order by is required here. Okay, distributes rows into groups. Percentage rank we already saw. Now the first value. So first value, if we run here, so highest salary, so we are saying find the first value, partition by department, order by salary descending, give me the first value, which is basically your, because it is order by salary descending, so my first value will be the highest value. So this is how you got the highest value. Okay, and syntax is same. And for the last value, this might be an interesting one here. So last value, if we, instead of first value, here first value, if we just simply replace this first value by last value, everything we are giving same, partition by department, give me the last value of this department, order by salary. So if we run this, what will happen? So we wanted the last value, right? So here we have this 60,000, but last value should be 50, right? Here we are getting 60. For 50 we are getting 50, but it is not giving you the last value, right? So for that, because why it is happening, because each row is just taking the last value till that point. Okay, till its current row. What is the last value till its current row? Okay, so for that we have to use this one. Like there are no boundation, we are partitioning by department, give me the last value from this department, don't put any boundation on my rows selection, right? So if we put this here, then if we run, now you see here we are getting the correct value, right? This was the 50,000 is the last value in this department, 60,000 is the last value in this department. Okay, so here what we are saying, rows between unbounded preceding, there is no boundation in like the preceding rows, and unbounded following. So the following rows also, like there should not be any boundation in the following rows compared to my current row. So basically check all the rows in my each department, because we are partitioning by department, right? So unbounded preceding and unbounded following. For example, if we are here at this row, yeah, fourth, then rows between unbounded preceding, remember our partition is happening on department, so for this row unbounded preceding is till this row, like arrow is this here, and unbounded following, so from this row unbounded following, go as beyond as you want, like following all, take all the values. So out of all this unbounded preceding and unbounded following, what is the last value? Is this one. So now I hope it makes sense. I hope now your window function is at least clear. Yeah, so if there are any doubts, please let me know in the comment section and I will try to help you out. And I hope it is clear. We will solve like questions based on this as we move on, like we were doing before. Like we will keep on solving some questions. But I thought like it is a good idea to just give you an overview of all the window function, because it's an important concept. So yeah, please let me know in the comment section how was it, and if you have any doubts, and I will see you guys in the next one. Okay, thank you, bye.